Hello and welcome back to Learn Python, your first step to data science. In this section, we're predicting disease progression using a disease progression dataset. And in this video particularly, I'm going to show you how we can import the diabetes datasets and explore its characteristics to help us understand the datasets and how we can use it to build a great regressor. Let's dive in and take a look. So I am in my Jupyter notebook, which is, if you have been following my videos for quite a while, is my favorite tool to show you guys what's up in the Python data science world. And it's a very good tool because it allows us to rapidly iterate between code and demonstration. So please open the accompanying code files in your course, and you would see that there's the chapter 4 IPYNB, and that stands for the code that we're going to go through today. And so in the first cell, if we can look at this, in chapter 4, we first import from sklearn, which is the module that stands for scikit-learn, a very popular machine learning library in Python that I've showed you in the last few videos. Inside this sklearn module, there's a submodule, or like a child module, if I may, that relates to the datasets that scikit-learn has on offer. Within that dataset module, we import a function called load_diabetes, which allows us to load the relevant datasets that we're interested in, which is the diabetes datasets that is relevant to this chapter here. So that's in1. In in3, we first create a new variable called diabetes data. It's really a placeholder for the object, the dataset object that comes back from the load diabetes function. And so we assign this a value of the return value of the function load diabetes. Okay? And with this, we first want to look at in5, right? So I'm here going to show you a very handy function in Python. And if you don't know it, it is actually quite useful to know. So you see it being in use in many situations, especially given the debugging situation of Python. It's quite difficult for you to, let's say, like look at some code, run it, and in real time sort of understand how the objects are laid out and so on and so forth. So this function coming up is actually very, very relevant, not only to data science, not only to this course, not only to machine learning, but generally as a Python programmer, you would want to use this. So this function is called directory, or dir, and it simply lists all the methods, properties, and things you can call about a particular object. Specifically in Jupyter Notebooks, because it's more of an iteration tool, dir lists out all the public functions of an object here in in5. And so we can see that diabetes data as an object has 4 different properties that we can call. Number 1 is descr, which stands for the description. Number 2 is data, which is the inputs that we feed into a machine learning model. Number 3 is feature names, which are labels or semantic names for the data columns that we have in the data property. And number 4 is the target, which gives us the target or the regression target or the output, whatever you want to call it, sort of like the correct answer that we can use to train our supervised learning machine learning model, right? So let's take a look at what this description is. So in diabetesdata.descr, it's actually a byte string instead of a string. So if you just take it out, it's actually fairly confusing to look at because all the new lines are bunched together. So the right way to do this is to print out the string so that all the new lines and the line breaks get interpreted correctly. So here we see some information about the diabetes datasets. There are 10 baseline variables. There are 442 diabetes patients, and we basically have measured 10 variables of these patients and also a quantitative measure of disease progression 1 year after baseline. So remember that the target that we're predicting is a change, not absolute value. And so the dataset characteristics gives you a good overview of what the dataset looks like, and it's generally a good idea for you to keep sort of a description or notice like this for every one of your datasets that you're working in real life. And so we have 442 instances, of which 10 columns, the first 10 columns are numeric, predictive values. And the target, which is at column 11, is a quantitative measure of disease progression 1 year after baseline. The attributes include the age, gender, body mass index, average blood pressure, and 6 unnamed variables that are useful to us. It says that these 10 variables have been mean-centered and scaled by the standard deviations multiplied by the num sample. So basically, the sum of squares of each column totals 1. And so now let's distribute this. So we want to first take the inputs, which is the diabetes data.data, and put it into a variable called inputs. And then we can go to diabetes data.target and assign these values into output as a variable. So that's in8 and in9. In in39, we look at the shape of the inputs. As we expect, there are 442 rows and 10 columns standing for the 10 numerical features. In in41, we look at the shape of the output. As we expect, there are 442 correct labels corresponding to the 442 inputs that we have. If we look at the diabetes data.feature names, we can see that there's age, sex, BMI, BP, S1, S2, S3, S4, S5, and S6, directly corresponding to the descriptions that we see here. So the next thing to do is to import pandas, as we all know. So import pandas as PD in in12. And in in23, we assign this new data frame that contains all the inputs with the correct column names labeled by diabetes data.feature names into df. In in24, what we're doing is we're concatenating df, which contains our input features, with a data frame that contains the outputs, and we want to concatenate this along the first axis, which is the column. Let's look at the data. We can see that the data is sort of bounded between positive and negative numbers, and in terms of magnitude, it's all quite small, so it's like 0.16, 0.27, 0.05, whereas the output, which is the last column on the right, has actually quite large numbers, whole numbers like 75, 141, and 206. In fact, we can use the describe function of the data frame in in27 to show the characteristics of this dataset. And as you can see here, there's a bunch of scientific notation that really doesn't mean anything to anybody. And also, it's extremely hard to parse what's happening. So this is a different way to do this. Neat trick, which is if we put style.format with a formatting string afterwards, we can get a pretty nice styled numeric data frame that makes things a lot clearer. And that's all there is to it. In the next video, we're going to go into understanding regression and linear regression. I'll see you guys next time.